Hello, statistics students. I've gotten, I don't know, 5, maybe 7 or so emails. I'm hoping that's a representative sample because I never hear from most of you that there are certain things from topic 17, the test of significance, where you're struggling with some of the concepts, some of the terms that they're using. Some of you are struggling with the technology part of it here. So I want to run through a completely different example. This is, I don't think, in your book. I want to go through the 5 different parts. I want to show you a couple of different options that you have for technology and hopefully give you some more confidence on this. So, in a survey from the U.S. Department of Defense back in 2011, a random sample of 500 active duty personnel showed that 24% were smokers. At the same time, so if we look up data here from 2011, the Centers for Disease Control and Prevention, gee, anybody heard of those people? Place smoking in the general population at 19%. Complete a test of significance to determine if American soldiers are more likely to smoke than Americans in general at the zero point zero 0.05 level. Okay, so a moment for that all to sink in. Of their 5 steps, they want you in number 1 to identify the population of interest and the parameter of interest. Well, I think we can do that in one shot here. The population of interest is American active duty personnel. Um, the parameter of interest here is, let's just say, hello. We're looking to estimate the proportion of soldiers who smoke. Now, the 24% that came from this one sample is in conflict what the CDC is saying is true about the general population. Do we have reason to believe that people in the military smoke more than Americans in general or not? Okay. So we're supposed to determine if American soldiers are more likely to smoke. So we want to figure out the proportion of soldiers who smoke. Okay, that's pretty simple. Number 2, again, you've got to get used to the wonderful statistic terminology here, the null hypothesis. So H sub 0, we're saying there's no difference. The proportion of soldiers who smoke is the same as the general population at 0.19. Okay, so again, if we suspect that American soldiers smoke more than others, those not in the military, we have to keep that suspicion and put that off to the side. Our null hypothesis has to be written in a neutral way, that the proportion of soldiers who smoke is the same as the general population, 0.19. Our suspicions come up here in what we call the alternative hypothesis, the H sub A. We're saying that the proportion of soldiers who smoke is actually greater than 0.19. Okay? We're going to set that aside. We're going to focus on the null hypothesis and be good scientists about this. Okay? Step 3, check whether the technical conditions are met. Again, there's 2 parts to it here. Was randomness included in selecting our sample, and was the sample size sufficiently large? Well, okay, they say here it was a random sample of people, so we can say yes to that. The sample size, you're going to need a calculator. These aren't too tough. We're going to, again, everything's based on our null hypothesis here. So the 0.19 times the sample size they told us up here was 500. So if we take 0.19 times 500, that'll give us 95. And again, that is greater than 10, so that's good so far. We also have to check the other. Now again, the complementary proportion here would be 0.81. So that turns out to be 405, and that is also greater than 10. Is the sample size big enough? Yes, it is. We are okay to proceed and apply what we've learned from our central limit theorem. Step 4 then is to calculate the test statistic, which you know better as a z-score. So again, from the survey that they took, it was 0.24 that they found as the proportion of smoke. Subtract the population parameter that from the CDC, the 0.19, and then we need to calculate standard error. So 0.19 times its complement, 0.81, and we divide by our sample size of 500. Well, this is going to be 0.05. Type those into our calculator there. I believe we're going to get a standard error of somewhere around 0.0175, blah, 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 which gives us a z-score of about 2.857. Okay, we'll go 4 significant digits there. I think that'll be good. So again, that's our test statistic. We're standardizing all of those numbers here. We're going to turn this into a z-score. How many standard deviations from the mean do we have? Again, we're going to take the distance between our observed sample statistic, in this case the 24%, and the hypothesized value of our parameter. Again, that comes from our null hypothesis. Step 5, then we're calculating the p-value. What's the probability of getting a z-score? Now again, we're going to use the same symbol here that we used in the alternative hypothesis. We suspect that soldiers smoke more. Okay, so we're going to look for the probability, the p-value, of getting a z-score of greater than 2.857. Okay, so again, it's important that you know if this is supposed to be greater than or less than or simply not equal to. Again, when you had the Texas Instruments calculators at your disposal, we went through how to find our normal distribution function there, put in the right z-score, what's the upper, what's the lower, and go from there. If you don't have one of those, all right, if you're okay using Desmos, I tried to show you this with some earlier problems. The issue here is the TI 84 pluses, the TI Nspires, Desmos, or other ones. You're going to have to learn how to get to the functions that you want to use. So again, with Desmos, the big pseudo red button there, start graphing. But it's not really a graph. We want to do a calculation here. Okay. Now, for Desmos, you're going to have to, And again, you can refer to this. You can put this in OneNote. I don't know, write it on a post-it note and stick it by your desk. What you need to type in is Normal. Now you'll notice here as I'm typing that, those letters to me look somewhat italicized. It's trying to figure out what I'm typing in, what I'm asking it to do. I keep going though. I'm looking for a normal distribution. Do you notice how once I finish typing a command that it recognizes the print of the letters changed? Okay. Now we also have this lovely little normal distribution is a function. Try using parentheses. Oh, why, thank you. And I really like how Desmos just pops up these little reminders for you. Okay, so we just want this. We've already standardized these statistics by turning it into a z-score. So we're going to type in 0, 1. The first number should be the mean. Second number should be the standard deviation. We're using our standard curve here. But notice how it also gives us this option of find the cumulative probability. And that's exactly what we want here. And here's min and max, stuff that you've seen before. So in our case, we want to put in that 2.857 as the minimum. And the default here is exactly what we need, the maximum going up to infinity. And as I'm typing that in, it automatically changes, recalculates instant by instant. That's our p-score right there. I'm going to snap a picture of that because that's exactly what we're looking for. In case that was a little bit too small for you to read. So again, you have to type in normal dist, Normaldist, open a set of parentheses, 0, 1. So we need the mean for a normal function centered at 0, standard deviation 1. Check the box there that says find cumulative probability. And as we did with the Texas Instruments calculators, figure out which way we want to go. Now again, for our particular problem, sorry, pasted that in there, we wanted this to be the minimum value, and we're saying that the proportion of soldiers who smoke is greater. Again, that's what we're suspecting, okay? So that tells us then we need to use our z-score, in this case the 2.857, as our minimum and leave the default there maximum of positive infinity. So let me scrunch this down to something much more. So we can say here that our probability of this just happening at random is 0.00214. That's our p-score. Great, wonderful, terrific. Now, if you don't particularly like Desmos, you can also try GeoGebra. I've used this one a lot with doing geometry constructions. Terrific. It's wonderful. It does 3D stuff, as you can see here on their homepage. Um, you can graph 3D stuff, and then you can grab it and turn it around. I really like this. You can do this same stuff on GeoGebra if you choose their option there for graphing calculator. Okay, but the issue again is if you're going to use GeoGebra, you've got to do it one way. If you're going to use Texas Instruments, you've got to do it a different way. If you're going to use Desmos, they do it their own way. Okay, so yeah, getting used to finding something that makes you comfortable and getting used to that. For GeoGebra, I type in normal, oh, look at all these lovely things. Desmos didn't even get into the Boolean cumulative. No, we don't want that. It's that very first one that we're looking for here. Okay, so we open a set of parentheses here, and again, our mean is 0, comma, standard deviation of 1, comma, and we had 2.857. Now that's not the same number we had just a minute ago. What's going on there? Now this, the drawback here with GeoGebra is sometimes we had to do this with the Texas Instruments and kind of fool it into doing what we wanted. This is showing the area, everything from the 2.857 all the way to the left. And that's the exact opposite of what we're trying to do with this particular problem. So you can easily get around that by taking 1 minus that number that you see there, and that will give us the same answer that we just had. Okay. The other way to do this is, okay, so we typed in this and it's like, oh no, wait a minute, that's way too big. There's no way that this is going to happen 99.79% of the time. No, no, no. This is giving us the wrong side of it here. So we can go back in and basically fool the calculator. I don't want everything from that point to the left. I want everything from that point to the right. So because of the symmetry of our normal curve, we can just flip it around and say, oh, well, if you're going to always give me everything to the left, I'm going to flip that 2.857 and turn it into a negative 2.857. And there's the exact same thing. Okay. So it's two different ways there, using online calculators and getting used to how they write this out. Okay, terrific. Now, the final part of it here. We calculated the p-value. There it is, a measly 0.0021, blah, blah, blah. We are then going to make a final decision here on the null hypothesis based on, now again, this is what several of you were asking about. We've got a significance level, that's what the alpha is there, a significance level of 0.05. So if we take that value of 0.05, is our p-value greater than the 0.05 or is it less than the 0.05? If we come up with something that's greater than, then we don't have very strong evidence that the null hypothesis was wrong. Again, we're focused on the null hypothesis, not the alternative right now. The null hypothesis. Well, in this case, the 0.05, okay, I'm sorry, let me line that up in the same color. 0.05 compared to 0.00214, this is less than. 0.05 is a really small number. And our probability here turned out to be even smaller than this. That's a good one there. So here's how we start off. We're saying our p-value is less than the level of significance. Okay, again, depending upon the problem there, it could be less than, it could be greater than. Oh, it's going to be so rare that it's exactly equal to. Okay, because the p-value is less than the level of significance, we found a probability that taking this random sample here is going to be at this value and just happens randomly is going to happen so rarely we reject the null hypothesis. Okay, the p-value is less than our significance level, less than that value of alpha. We can reject the null hypothesis. That's exactly what we're going to do here. So then the next part of it there is, all right, we reject the null hypothesis. What does that mean? This implies the proportion of soldiers who smoke is actually greater than the general population proportion of 19%. Remember, if we go back to what we had for our alternative hypothesis, we are going to, in this case, because we came up with something that's even lower than this significance level, we reject the null hypothesis, which implies our alternative hypothesis must be true. Okay, got all that? Now again, the other side of this here, if you get a p-value that's bigger than our significance level, then we fail to reject the null hypothesis. And that implies that the population proportion that we're trying to estimate here could be the value that's in that null hypothesis. We don't know. Okay, so hopefully this gets you on the right track, gives you a bit more confidence about tackling these things. And again, through either GeoGebra or Desmos, um, typing in the right function to get the online calculator to do the calculations you want. That's going to be hopefully a hurdle we can get over now. All right, so take a look at this. You might rewind it, start it all over again. Again, the 5 steps. Identify the population parameter of interest. Write out the null and alternative hypotheses. Check the technical conditions. Make sure the sample size is big enough. Calculate our z-score, the test statistic, normalize things. Calculate our p-value, the probability that this just happens because of random sampling. And then make a conclusion here based on our significance level of whether we reject the null hypothesis, implying the alternative is true, or we fail to reject the null hypothesis and we're not really sure. So go back now and take a look at those problems that you did from 17. Maybe use the calculator function a little bit differently, maybe write out some of your answers more completely, and I'll talk to you guys soon.